So let me introduce Carlos Chaccour to talk about the efficacy and safety work streams and implications.
Good afternoon. So what I'll try to cover in these 15 minutes, it's first the user scenarios that we discussed during the development of the roadmap, and then I'll talk briefly on two key concepts that are based for efficacy of this approach, and those are the drivers of the efficacy and the mosquito susceptibility, and then I will use the trials that are upcoming in the next few years and the different doses and treatment schemes that I have selected to compare them and talk about safety and efficacy in the context of those two potential regimens. So the user scenarios, as discussed during the roadmap, in a very simple schematic way, we define settings, a rationale for each setting, a target population, and a deployment width, which is basically what other interventions could accompany ivermectin into this, or the other way around, what ivermectin could accompany. So we define higher and lower transmissions arbitrarily without a specific number to these two. And then for the higher transmission, we said that the rationale would be to reduce vectoral capacity, to reduce disease burden, and address residual transmission. The target population would be humans or livestock or both, and the ideal companion to this would be always vector control and case management, and then consider using ivermectin in combination with SMC, either to boost SMC that is given to the children, or to use the platform of SMC not only to treat the children with SMC and ivermectin, but also as an entry point to treat the whole family with ivermectin, making a mini MDA in each household. And then consideration of combining this malaria intervention with other entity interventions as a comprehensive approach. And then for the lower transmission, we thought as a way to accelerate through elimination and address residual transmission as well. The populations are the same, but then the companions would be as above, plus MDA with an antimalarial to try to crush down the transmission from whatever lower point it is to zero, and other livestock health interventions that Cassidy would touch upon later. So two key efficacy concepts are the drivers of efficacy, and I'm sorry to show this yet again. I'm sorry I bored you to death showing this slide over and over, but it's important to remember that mainly it will be driven by the levels that are reached in the blood of the people who have taken the drug and how long these are present. And these two can be combined in what is called the area under the curve in PK terms. And then finally, a third concept, which is how many people are covered or how many blood sources are covered if you want to bring livestock into the equation. There are other determinants of efficacy, which are a reduction of the sporogony that is proven, a reduction of mosquito fertility, and a reduction of mosquito fitness. These are difficult to quantify, and it's not well established how much of the contribution of these other factors will be, but they're there, and it's probably not negligible. Mosquito susceptibility is an important concept. And this is just a few of the experiments done in the last 3 years. And if you look at this table, this is different methods. So some of these are not directly comparable, but it would give you an idea that you have some species that are in the single digits. That is Gambi, for example. If you feed it 6 nanograms per milliliter of ivermectin, more or less 50% would die within 10 days. For Oti, more or less 99% in about 12 days with just as little as 2. So some of them are in the single digits, some are in the double digits, but then we have a problem with this guy here, Aldimanus, and this is a recent paper showing that it's in the 4-digit numbers. So this is basically unkillable with ivermectin. So that's a problem we have there. If you order this from less susceptible to more susceptible, you end up with this list here. Know that the African or the key African vectors are here. Nobody has done Fenestas, somebody should. And what this brings is the concept of dose-defining species. If you want to devise or you want to design a dose to target all of this, then you need to aim at a dose that is high enough to target these vectors up here. And this once becomes your dose-defining species. If you want to target just African vectors, then you can target to the less susceptible vector present in Africa, which is probably down here. A linked concept to this is the window of escalation. If you end up defining a high starting dose because of a species that is that is less susceptible, then those that are more susceptible could gain resistance, and you wouldn't notice, and there wouldn't be any phenotypic expression of it until this resistance is very high. An open question with this list would be, should we define different ivermectin doses for different geographic areas? Note that the Asian and Latin American vectors are up here and the Africans are here, so that's an open question there. What is about to happen in the next few years, I think is very exciting. You can read more about each study in Mesotrack, which is a very good resource for those keen on knowing what's going on. And there we have mapped at least 6 groups working on this in the next few years. They're working, some of them in West Africa. Our own proposal is for Mozambique and Tanzania. There's a group working in Thailand. And what you can see is that there's different doses there. Many are using a dose that is, I've put here as 303, and I'll explain more. And then the combinations in these trials go from ivermectin alone, in some of them, to MDA with antimalarials, to SMC in others. In this case, for example, SMC is used as a platform in which ivermectin is given to the children together with SMC, but also to the rest of the family. So different doses. The label includes onco, LF, and scabies in these doses that are here. But then how come everybody's talking about 303? And this is because of the ivermal trial that has been presented here in the last 2 years, different results, but it was finally published earlier this year in the Lancet Infectious Diseases. And tomorrow they will present the results of pharmacogenomics here in the Marriott at 9:30 a.m. You want to go see them. So how's the comparative PK of these different doses? So the 400 one, which is one of those proposed for those 6 studies, looks like this. You get a peak of about 60 nanograms milliliter at 4 hours, and then it drops, and you would have about 10 to 14 days of measurable concentrations. I have put 3 doses separated by 30 days here to remind me to tell you that you will need to repeat this approach during the rainy season a few times. The 303 looks like this. This is model data, not from the study. And it would be an intervention that is repeated during the rainy season as well. So it wouldn't be just single. It would be every month you would have an intervention consisting of 3 daily doses. And the PK data of the ivermal paper trial has been also recently published. So how do they go head-to-head in terms of PK? 400 is here in purple, and then 303 is right here. And the main, what is noticeable is that the Cmax is very similar, and the advantage of the 303 is additional time with measurable concentration and also additional area under the curve. And you can see the numbers here, right? The Cmax is very similar, around 60s, but the area under the curve, remember, is one of the drivers of impact, is almost double or more than double for the 303. And these are the onco and scabies doses for comparison. So what would it look like in the field? And we had Hannah Slater do some ad hoc modeling for us. And what she modeled is what would happen with 3 interventions, either 400 once on months 1, 2, and 3 during the rainy season, or 303 on months 1, 2, and 3 during the rainy season, and what would happen in terms of malaria incidence. And what it looks like in the model is like this. The controls get a peak of transmission. This is modeled for this area in Mozambique. And in both cases, transmission drops significantly. And as expected, the 303 does better than the 401, as shown by this gap here. The question is, this seems to be in the model. The question is, how big would be this gap in a trial, in the real world? So some efficacy and R&D questions that we defined in the roadmap is to compare both doses in the field, not against each other, but to measure the impact in the field, and particularly looking at the trade-offs between deliverability and effectiveness. Also, these new formulations that are being developed, and you probably remember Bellinger that was presented here last year, and this device that opens in the stomach and stays there for a few weeks. And then an interesting approach is doing dose ranging studies to try to get rid of the inherited adjusted by dose, by weight dose that we have received from the veterinary users of this, and try to have a fixed dose that would make operations very easily, as you would have with any other antibiotic. Potential game changers, not ivermectin, but new molecules that are being developed that have a fantastic profile, much better than ivermectin alone, and have not only a PK and a half-life that is measured in weeks, but also the possibility to target AEDs, which is a huge advantage. As far as I know, there's still no first in human with these drugs. Key safety concepts, since we have been continuing after efficacy. One key concept for safety would be accumulation. So if you're talking about repeating this during the rainy season, then is there chances that this would accumulate and cause toxicity? Well, in this graph, there's half-life of the drug here, increasing by, for example, drug-drug interactions, and then accumulation. And this is in percentage, and here is less than 1%. Ivermectin's half-life is around here, 16 hours. And if it were to prolong all the way to 75 or 100, it wouldn't reach 1% of accumulation if it's given every 30 days. So that's a reassurance. If you zoom out from this graph, it looks like this, right? That 100% of accumulation is up here, and it would accumulate to very, very little if it's given every 30 days. Pregnancy is the other key question of safety. And little data, there's a systematic review by Patricia Nicolas, and it's almost ready to go. And we have identified 893 documented exposures during pregnancy, and of those, 97 were done during the first trimester. And in terms of miscarriages or stillbirths, or in terms of congenital anomalies, the results are very similar. Few trials or few studies, not trials, few studies, wide confidence intervals, and no evidence of harm. So, is there evidence of safety for higher doses, specifically for the 303? And you can look at this from the Cmax point of view or from the AUC point of view. From the Cmax point of view, I already mentioned that it's very similar to the 401, and this is in the label. So I don't think this would be a regulatory issue, because it's very comparable to something that is already approved. From the AUC point of view, we try to compare it to, first, to an out-of-label recommended use, and the CDC recommends for crusted scabies up to 7 doses of 200 micrograms kilo on days 1, 2, 8, 9, 15, 22, 29. That's for very severe scabies, crusted scabies. And it looks like this. This is the comparison of the 303, and this is the severe scabies dose. And the AUC of the severe scabies that is out of label but recommended is much higher. Another way to look at this is to try to find studies that have given higher doses, such as 800 accumulated either during a week or 800 in a single dose, and compare it. So we found these studies, and between all of them, at least 2,100 people have been exposed independently to a single dose of 800. And this looks like this. It looks a much higher peak and an area under the curve that is very much comparable. So is this enough evidence to go forward? Well, I think it provides a very good background. So to summarize, the doses and schemes that will be tested in the next few years, the 303 has the advantage of that you can expect a higher impact in the field, and the regimen matches very well SMC and antimalarial MDA schemes. The disadvantages is that it has an unknown coverage on adherence yet in the field, that we have to prove it, and the regulatory pathway is probably a bit more cumbersome because we have to change not only the label but also the dose. The 401 has proven coverage and adherence in billions of people in NTD's programs. The dose is in the label, and it's aligned with NTD's objectives. However, you could expect a lower impact, and remember, this dose is not used in all LF areas. So safety R&D questions is to establish the safety profile of this new higher dose regimen, to see if this could be given to potentially pregnant women or smaller children thinking about higher coverage, which is a driver of transmission, and to see whether there would be important drug-drug interactions that could affect the efficacy or the safety. And this is the list of the road mappers. And thank you very much. All right. So we have about a few minutes for any specific questions about this talk, and then we will open up for general questions at the end.
Julie Jacobson, Bridges to Development. Just one quick question from your, you looked at the 800 milligrams that's only been given in certain populations, and the area under the curve, it didn't have the tail, but it looked like it was very similar to the 3 doses at 300. Is that at all in your thought process as well?
The tail, it's in the drawing, but the calculations of the curve include the tail as well.
It ought to be pretty close, actually. So I'm curious.
We can't hear you.
So the question I have has to do with. I just said from an algebraic standpoint, 3 times 300 and 800 ought to be pretty darn close in AUC. So they will be essentially very close to one another. The question I have deals with active metabolite, right? So Kevin's got data that basically shows when you're below his IC50 value, he's still killing mosquitoes. It's kind of amazing, which makes you think that there's something else going on here. So I'm curious how you're thinking about all of your results, particularly for safety and accumulation, if you actually have a presence of an active metabolite, because that's going to actually contribute potentially to your accumulation and factors related to that.
Well, Ivermal was published first. They published their mosquito results, and then just last month they published their PK results. And they have this fantastic data set in which they can compare mosquito mortality against a specific concentration in 141 people who were randomized to either 603 or 303 or nothing. And in these results, according to their model and what they actually measured, there is no need to invoke unknown factors such as active metabolite to explain what they saw in terms of mosquito mortality. There is still a group that is funded to look into this, and we'll probably have results very soon.